Welcome to qnawire.
So for question 25, we want to show that this equation, psi equals a sine of kx, is not a solution to equation 40.23, which can be written as negative h bar squared over 2m multiplied by the second derivative of our psi function plus u of x psi of x, which equals e times psi of x. So for part A, showing that this is not a solution, we first want to take the double derivative of our psi function. So the first derivative of our psi function will go to ka cosine of kx. And then the second derivative will go to negative k squared a sine of kx. And we can see that a sine of kx is our original psi function. So we can rewrite this as negative k squared times psi of x. So now we know that k squared can be written as 2me over h bar squared. And we want to solve for our k. So we can take each side to the 1/2 power. So k equals 2me over h bar squared to the 1/2 power, and this can be simplified to 2me to the 1/2 power over h bar. So that is our value for k. And we can see that h bar squared times k squared over 2m plus u naught is greater than u naught, which is greater than e. This is if k is real. And we solve for k as the square root of 2me over h bar. So we can see that this psi function is not a solution to equation 40.3 because it is not consistent. So that is our answer for part A. And for part B, we are asked, is this psi a solution for if E is greater than U naught? So in this case, if E is greater than U naught, then we want our psi function to be consistent. So to do that, we want to find the boundaries of our particle in the box and see if the boundaries equal each other. So to start this out for part B, we can set psi of 0 equal to psi of L, which are our two boundaries of the box. We want to set these both equal to 0. Sorry, it's a 0. And now we want to apply our boundary conditions. So we will plug in 0 for our psi function. So psi of 0 is going to equal a sine of k times 0, and sine of 0 is 0. So we have a times 0, and psi of 0 equals 0. For our next boundary, we have psi of L, and we will have a sine of KL And we can plug in for k n pi over L multiplied by L. So you can see that these L's will cancel. And so now we have a sine of n pi. So sine of n pi is going to be 0 for any n that's an integer. So our psi of L is also equal to 0. And so we can see that our psi function when e is greater than u naught is now consistent. So we have if e is greater than u naught, then h bar squared times k squared over 2m plus u naught equals e. This is consistent. So for part B, our psi function is a solution to equation 40.3.